Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today is the 12th of April. Okay, 12th of April. And today we will continue back with slide 12, chapter 3, under 3.2. Okay, so what we have learned in chapter 3 is basically we are talking about process concepts. Okay, so we have understood what is a process. Okay, what is the difference between a process and a program, and how the process is being brought, or how is being brought from, or how is it being run, and how the program or the files are being brought from the hard disk into the memory, and finally into the CPU to be processed or to be run. Okay, and how we also have understood how each process runs and how each process is being terminated. Okay, so in this chapter 3, we have also described how each process talk to one another. Okay, and the most important thing before we continue today is, oh yeah, this one here. This is a diagram that you need to understand. Okay, the process state diagram is basically telling you from what state the process was or the program is until it's being processed in the CPU. Always remember, the CPU can only process one program. Okay, can only do one program. However, it can do, because of its time slice, because it's being processed at a very fast speed, it can process. It looks as if it's processing a few processes at one given point of time. Okay, and always remember, each process that is being processed by the CPU, the program or the files are kept inside the memory, which is inside the ready state. Okay, so I'll explain to you about this diagram again. Okay, so for each process to run from the start until the end, it has 5 states. 5 keadaan, that means each state. Okay, what is the state before it's run, and so on and so forth. It's like it's like your car. Before it starts running, it'll be in several states. Okay, it's waiting for something, it's waiting for an input, or so on and so forth. Okay, yes, although you see your car now is not being has not been started, but it's already in a different, it's already in a specific state. Same goes to your phone. Your phone is on a waiting state because it's already on, it's waiting for any messages to come in or any phone calls to come in. It's not that once, if the phone call comes in, only then you on your phone and so on and so forth. But okay, it is on a waiting state. That means it's running and it's waiting for something to happen. Okay, so some processes can be immediately processed. Okay, some process can be immediately processed. For example, like the calculator. Okay, sorry. For example, like when you're doing programming, you put in all the inputs and immediately it's being processed. Okay, like Microsoft Word. Okay, it's a process. Okay, you can just type in immediately. But certain processes, for example, like on your phone, when you want to make calls, the program or the program that make calls to, it's waiting for an input. Once you type in the phone number, only then it can start making a phone call. Same goes to your WhatsApp messaging program. It's waiting. Yes, the program is now running. It's waiting. It's there ready, but it's waiting for something to happen. It's waiting. Okay, because it cannot do anything else. It only receives messages and notifies you. Okay, it only receives and notify, and send out messages. So if the user does not type in any message and there is no message coming in, so it's on a standby mode. So it's still there, but it's only waiting. It's a waiting. Okay, it's a waiting state. So that goes under this category down here. Okay, so the program is inside the new state. The new state is always inside the hard disk. once the user double clicks on it, the program is now brought in or admitted into the ready state. The ready state is inside the RAM memory. Okay, so inside the memory, there are few programs running at one. There are a few programs inside the memory, and each program will be given a short piece of time to be brought into the running state to be processed. Okay, to be processed, to be run lah. Okay, so there are several types of methods or ways for the process or the program to be brought from the ready to the running. One way, one method is by creating an interrupt, meaning, let's say in the CPU there is a process being run and the process needs a file or a program inside the ready. So the CPU will create an interrupt, stop the program or stop the process, go and get the file from the ready state and bring it back into the running. So there is a dispatch scheduler, a scheduler dispatcher, which is a software program which actually brings the bring the programs from the ready into the running state. Okay, or maybe now the process has been run, but it's waiting. For example, like your Microsoft, your WhatsApp message is waiting for something to happen, so it goes into the waiting state. Okay. So what is a waiting state? A waiting state is exactly like how your WhatsApp program works. It's once you on your phone, you're on your WhatsApp, yes, it's running. Okay, but once you close, you minimize it, it's waiting. It's waiting for what? It's waiting for a message to pop in. Once the message pops in, then the program, okay, will be run again. Okay, will be run again. So in the meantime, it's just waiting. It's waiting for an input to happen because the WhatsApp program can only run once there's an input. What type of input are we talking about? When he receives message, when he receives picture, or when you want to send out something, so there's an input or an output as well. Okay, or it's waiting for a completion of something to happen. Example, let's say you are running a program or you're opening your email, for example. Okay, you're opening your email and you're sending a file, okay, through email. So the file is big, so okay, so there's an event happening. So the display message saying that your email is sent cannot be processed until that event of sending out the email occurs. Okay, so there's an event to complete, only then it can move on to the next screen and so on and so forth. Okay, so again, there are 5 states: new, ready, waiting, new, running, waiting, ready, terminated. Okay, so if you read it from the diagram, it's new, ready, running, terminate, waiting. Okay, always remember these 5 states, and you must know you must know how to describe each state. This is always very important. It always appears in your test and your quiz as well. All right, let's move on. Each process has a unique ID, which is called a process control block. A process control block is a unique ID for each process. So inside this PCB, process control block, there are several types of information. One is the process state. So what is the process state? As I explained to you, it either can be a new, it can be a ready, running, terminate, or waiting. So these are process states. And also has a process number, and any number given by the operating system. Program counter. What is program counter? Meaning to say when, okay, location of the instruction or location of instruction to execute to next execute. What do you mean by next execute? Okay, inside a particular process, there are some instructions. These instructions will tell the CPU, okay, what to do, how to get, and so on and so forth. So the program counter always keeps a the instruction of the next thing to do. Okay, of the next thing to do. And then we have registers, CPU registers, AR, BR, CR. Okay, I'm sure you will remember this in your assembly language. Okay, So these are registers and memory limits. How much of the memory can each process take? Okay, because you have to remember these processes are all are all ready inside the RAM. So they need to be memory allocated to them. And what are the type of files which are being used for this particular process? Okay, so these are certain information inside the process control block. Okay, so let's move on to today's lecture. Today's lecture, we are going to talk about process scheduler. Okay, process scheduler. We are going to talk about this part here, the scheduler dispatch over here. Okay, over here, the scheduler dispatch. Okay, so to maximize CPU usage, quickly switch process onto CPU for time sharing. Process scheduler selects among the processes for next execution on the CPU. All right. Okay. So there is a software called process scheduler which chooses each process from the ready queue into the CPU. So it will choose. Some process needs two things to run. Some process dia boleh run macam tu je. Some process, in order for it to run, it needs something to be inputted. So it needs something from maybe the scanner. For example, you open the scanner program. The scanner program it cannot run more than that. It can only, yes, it opens. Once it opens, it's waiting already because it cannot continue more than that. It only can run more once there is an input from the scanner. Okay, a scanner program, even Microsoft Word. Microsoft Word, yes, the running state is when it's being loaded. But once it has been loaded, that's it. It cannot move on. The process stops there because there is no input from the user, which is you are typing the keyboard. Okay, so there are several things that is related here. One is the ready queue. The ready queue only looks at the process. Okay, we also have another queue which is called the device queue. Why is that so important? Because the device queue keeps track of all the input output devices. Because sometimes there's only maybe the input is being used by another process. The input is used by another process, so this process has to wait. Okay, so this process needs to wait for an input by the device. Only then it can continue running. Okay, so inside the ready queue, set of all processes residing in the main memory, ready and waiting to execute. And then there's also another another queue, which is called the device queue. Set of processes waiting for an input-output device. So the device queue keeps all the processes which are waiting for the input-output. So that's important. Okay. So the CPU scheduler will choose between two types of process. One process can run immediately. Another process needs to wait for the input-output. Okay, so there are two types of process. One is called the process which can run immediately. That means there is no no requirement from the input-output devices. Example, when you want to scan your antivirus, you're scanning your antivirus. It's just a program. It runs by itself. There is no need for any input-output from any user. Microsoft Word, yes, there is a need. Yes, it can run in the beginning, but it needs an input from the user. Only then it can go on. So there are two types of process here. One is called the ready process. Okay, we'll see the name, the exact name later on. Another process is it needs a input output to run. Okay, so inside the ready queue, there are separate queues as well. There are processes ready waiting, and another process pasal device queue. Okay, so here we go. So in this diagram, it's explanation about what happens in the ready queue. As you know, the ready queue pushes or brings the process from the ready state inside the CPU. So there are several types of process. One process is waiting for a request to happen, like WhatsApp. It's waiting for that request to happen, only then it can start processing. Okay, but that that input output could be used by another program, so it has to wait. Another example of waiting for an input output. Let's say now I'm running on WebEx. Okay, I'm using the camera, but at the same time I also want to run my Google Meet, for example. Is that possible? Because I'm using the camera and I'm using the mic and I'm using the speakers. Okay, so it's not possible because at this program I'm using this, but that program cannot use this because this output is used by this process. Only only if WebEx is closed, only then Google Meet can use the camera and the mic. Okay. All right. So there's a time slice here. Time slice means when each process finishes certain period of time, then the other process can use it. For example, let's say I'm running WebEx and Google Meet. Okay, after 10 minutes using this, I shut down the WebEx or I close the the mic and the screen for this WebEx. Then I can use the Google Meet. So there's a time there. Okay. Next, there was also something which is called the fork a child. Fork a child means, okay, it means that the process is broken down into a separate sub process. Okay, biarlah diproses sendiri. Example of a fork a child is like when you're using Microsoft Word and then you go into a sub process which is called print. Once you start printing, then that print program too, that the print process too, is called a child execute because it's executing by itself. It's nothing to do with me. I mean, it's all about my process, but it's executing by yourself. It's executing by itself. Only when there is a problem inside the printer, ink habis ke, printer jam ke, or so on and so forth, only then it comes back to the actual process. But since it can handle itself, it's what we say as a child execute. Or if the process is interrupted by something. Okay, let's say the process is now waiting or it's being interrupted. Okay, for example, let's say you are running Microsoft Word, tiba-tiba there is a virus, so pump, the error message comes out. So that is an example of interrupt occur because another process comes comes over the previous process. So that's what we say as a interrupt. Okay, so inside the process scheduler, there are two types of scheduler. Where am I talking about? What am I talking about? I'm talking about this one here, dispatch scheduler. Okay, so dispatch scheduler punya kerja ialah bawa proses from ready to running, bawa proses from ready to running, bawa proses from ready to running. So inside the dispatch scheduler, there are two types of scheduler. One is called the short term, one is called the long term. Okay, all right. So what is the difference? Because the dispatch scheduler needs to bring all the processes from the ready queue into the running. If it brings process yang asyik-asyik nak wait, because always remember the CPU can only run one process. Kalau dia bawa semua proses yang banyak pakai CPU, then proses lain macam mana? Or banyak dia bawa pakai proses yang waiting for something. If the process is going to, let's say, it brings in 5 processes that is waiting for an input output to happen, then what is the CPU doing? What are you doing? What is the CPU doing? It's waiting untuk input output. Kelima-lima ni is doing waiting for input output. Okay, so we have two types of scheduler. One is called the short-term scheduler and one is called the long-term scheduler. The short-term scheduler chooses the process from ready to running, ready to running, ready to running. So short-term scheduler ni is very, very fast. It only chooses a process from ready to running, because CPU is moving very, very fast. So it needs to choose all process frequently. A long-term scheduler, on the other hand, chooses a process from new to ready. So bila you click something, bila you click a program, then the long-term scheduler will get the particular file from the hard disk and bring it inside the ready queue, which is the memory. So why do we need these schedulers? These schedulers are important to keep track the number of programs or the number of process which can be run by the CPU. Okay, because if you do not have a scheduler, then the process or the programs can be jumbled up. So the operating system provides a scheduler, okay, to keep track of all the processes. And then if you can see here, the long-term scheduler controls degree of multi-programming. We'll cover that in the next slide. And each process, there are two types of process: input-output bound process and CPU bound process. What does this mean? A CPU bound, an input-output bound process means, means that the program or the process is doing more input-output rather than computational. A CPU bound process is doing the other way around. Banyak buat kerja-kerja computational, less of input output. Okay, example, WhatsApp program is what we say is a input output bound because memang dia punya kerja dia banyak buat on input output. Okay, banyak buat on input output. A CPU bound process example is like antivirus. Okay, because it's dealing with all the files. Okay, you scan this. Okay, these are all CPU bound processes. Okay, because it's not waiting for any input and the output, it's immediately being processed. So a long-term scheduler strives for a good mix. What does that mean? A long-term scheduler, a good mix. That means bila dia buat process from new to ready, it has to choose. That means the processes yang dia bawa tu, it needs to be a good mix. That means it tak boleh lah bawa semua CPU bound, tak boleh bawa semua IO bound. Because if it bring, let's say it brings semua proses yang input output bound, then the process dalam CPU tu dia akan jam. Because why? Because if all the processes inside the CPU is waiting for all the input output devices, then there will be a problem lah. Because all of them are waiting for the same thing. All of them are waiting for input from the keyboard. All of them are waiting an input from the scanner, and so on and so forth. Okay, so the long-term scheduler will choose processes or programs. Either it's CPU bound or input output bound. So you choose. Are you all okay there? Faham tak? Do you have any questions to ask me?
Okay, sir.
Okay, sure. Sure?
Yes.
All right. Okay, next we are looking at medium-term scheduler. What? Oh, sorry. Haikal ada tanya soalan. Yes, Haikal. Haikal. Haikal? No? Accidentally pressed? Okay, never mind. Okay, so now, you dah tahu short-term scheduler, long-term scheduler. What is short-term scheduler? You should know. What is long-term scheduler? You should know. Okay, so short-term scheduler brings ready to running. About process from ready to running. All right, long-term scheduler, new to ready. Okay, that's in your mind already. Next, we have something called the medium-term scheduler. Medium-term scheduler can be added. This is a very important word. Can be, boleh ditambah. If degree of multi-programming needs to decrease. Sudah. What is multi-programming and what is degree of multi-programming? Multi-programming, give example. Multi-programming operating system has the ability to execute multiple programs with using of only one processor machine. One example is user can use Excel, download apps, transfer data from one point to another point, Firefox or Chrome browser, and more at the same time. So multi-programming means okay, the system can run more than one program by just using one processor, which we are doing now. Okay, so your laptop, your desktop, your phone can run multi-programming simply because you only have one processor and you are running multiple programs. So dalam example ni dia bagi lah Excel, download file and so on and so forth. So these are program and you are running it using at the same time using one processor. Okay, alright. So the degree itu dah pasal multi-programming. So the degree of multi-programming describes the maximum number of processes that a single processor can accommodate efficiently. Okay, the degree of multi-programming maksud dia ialah the maximum number of processes that a single processor system can accommodate efficiently. That means what is the maximum number? 10, 20, 30, 40, 50? We are not sure. So the degree of multi-programming means that what is the maximum number? What is the maximum can? So the OS has to put a stop to this. Okay? So bila dah banyak sangat, so the OS comes up with something which is called the medium-term scheduler. So medium-term scheduler is remove process from, it's a condition whereby the OS removes process from the memory, stored it on the disk, bring it back from the disk to continue execution. And once it brings back, it's called swapping. Okay, so the degree of multi-program, so what does this mean? Meaning to say, if there are too many programs running at one point of time, then operating system akan keluarkan a scheduler, which is a software, to remove the processors or the files from the programs from the memory and place it inside the hard disk and bring it back when the CPU is free or the memory is free. Okay, so this process, remove from the memory, store it on this disk and bring it back, is called swapping. Okay, so medium-term scheduler is added if degree of multi-programming needs to decrease. So degree of multi-programming is maximum number of processes that can run. Let's say the maximum number is 10, and the CPU somehow it goes above 10 because too many processors, too many users, it goes above 10. Then automatically operating system will signal medium-term scheduler to swap the processors from the ready back into the new, and then once CPU dah clear, then pass it back inside. Okay, pass it back inside to ready. Okay, so medium-term scheduler swaps the process out of the ready back into the new, and once the system is clear, bring out the process from new back to ready. Okay, this concept is called swapping. So the degree of medium-term scheduler only comes out or only is added if and only if the degree of multi-programming is high and there is a need to reduce it. Degree of multi-programming itu apa? The maximum number of processes that the CPU can run efficiently. Maximum number. So let's say it can run 100 processes, but sometimes all the processes are jammed up. So we use swapping. Okay, so swapping means, or we use medium-term scheduler, operating system will swap out the process, keluarkan, letak balik dalam new, which is the hard disk, and run whichever is possible. Once the habis semua process, then you bring it out again. Okay, so alright. So in mobile phones, the concept is a bit different when you're talking about mobile phones. Mobile phone, we are talking about multitasking. What is multitasking? Multitasking is different from multi-programming. Multi-programming tadi, we are talking about multiple programs. Satu program, multiple lah. Download, YouTube, Excel. So these are different types of program. Okay. In multitasking, we are talking about one program, banyak kerja dia. Okay, one program. Okay, so in the initial state, the early version of iOS, it only allows one process. Okay, one process, single foreground. That means whatever you see in input is only one process. Yes, but you have multiple background processes in memory running, but not on the display. Okay, so one process is in the single, one process in the foreground, but nothing. But behind they are running lah. Behind they are running. However, Android pula runs foreground and background with fewer limits. That means it can run both, sama juga. Okay, but fewer limits. Dia ada limit dia lah. What it can do and what it cannot do. Okay, so on and so forth. Context switch sama juga macam swapping tadi. That means bring out the process from ready and letak balik dalam new, and bila dah habis, bring it out again back to ready. So when the CPU switches to another process, bila dia bertukar or when it's changing, the system must save the state, because bila you bawa keluar proses from ready to new, okay, you have to save it. Whatever is being done ke apa, you have to save it. So save the state and bawa balik ke dalam new and pass it back. Okay, so that is also considered context switch. All right. Okay. So we stop here. I think today is a bit heavy. We'll stop at 3.3, and inshallah, we will continue in the next class about 3.3. Okay. All right. Thank you. Sorry, you have any questions to ask me?
Sir.
Yes. Anyone want to ask me anything? No. Yes. Tak dengar suara sir. Aziza, can you hear me? No.
Yes, sir.
Oh, tadi.
Boleh.
Oh, tadi.
Tadi jawab.
Okay. Alright. Okay. Alright. Thank you so much. Inshallah, I will see you in the next class. Next class kita pada hari Wednesday, 3B, and 3A pagi at 9 o'clock, and which is tomorrow lah. So morning tomorrow is 3A, and tomorrow afternoon is 3B. Okay. Alright. Inshallah, I'll see you tomorrow, and we will start back at chapter 3.3. Alright. Thank you so much. Assalamualaikum warahmatullahi wabarakatuh.